Okay, let's discuss robot jogging or jogging the robot. Okay. So, uh, the as I stated before, jogging the robot means that we're going to manually move the robot arm to a position. So we might do this for maintenance. We might do this as part of the teaching process. Okay, and to do this, we need to use the teach pendant. All right, so uh, here we're going to discuss jogging. We'll talk about the axes, how to move the various axes, and also use various coordinate systems to jog. Okay, so when the operator jogging is when the operator is controlling the robot. So the robot is not running in automatic mode at this point, but we're using the teach pendant to manipulate the arm into a position of our desire. So when you're working with this, you're going to be holding the teach pendant. The teach pendant has an emergency stop on it, and there's also some other emergency stops around. So always be aware for safety about the emergency stop on the teach pendant and any others that are available depending on your work cell. Okay, you also need to make sure that if you're running the robot, that you are in view of all machinery and all areas of the robot arm, and that no other people are near it for safety, obviously. Okay, so the teach pendant is your jog point. Okay, the teach pendant is your point, your control of the robot. The robot's not running an automatic, so the fence or the door may be open, and the operator holding the teach pendant is the only one who should be near the robot, and they are in control, and they have uh, the ability to start or stop that robot. Okay. So, as I said before, jogging is used to move the robot to a point to teach it to and teach it a point and a program it should return to, or to recover from what's referred to as a crash. Crash is when the robot stops because either it hit something or some other error occurred that caused the robot to stop, or a singularity fault. Okay, singularities are what happens when the wrist component of the robot axes 4, 5, and 6 are all in line, and the problem is that it doesn't know which joint to move first to get to the next position. All right, so one of the things we need to be concerned about is the speed. So if you're going to jog the robot, you need to think about, how fast are you going to move it? And the other is what coordinate system you're going to use to move it. All right, so the jog speed is actually set by the ISO safety standards. So the ISO safety standard says regardless of how fast the robot could move in auto speed, if you are running the robot in manual mode, or what's usually referred to as either teach mode or jog mode, then for safety reasons, you're not allowed to move the robot more than 250 millimeters per second. Now, that's referring to the speed of the tool center point, which we discussed before. And so the 200 IC robots that we have in the classroom, and full automatic production speed, they can actually move the tool center point up to 4,000 millimeters per second, which is approximately 9 miles an hour. And so when you're talking about it's only moving a few feet, I mean, that's moving pretty fast. Okay, and so, but like I say, when you're in jog mode, the fastest you can move is 250 millimeters per second. okay, which is approximately 6% of maximum production speed. Okay, so here's a picture of a teach pendant, and there's two keys there. You can see like kind of outlined there in blue. They have a plus percent or minus percent. So these allow us to increase or decrease the speed. So if the speed, and the speed, you can't really see it in this slide, but up in the top right corner of the teach pendant, there's a little green box there that says 100% or whatever percentage that it's at. So if the that display is saying 100% and you're in jog mode, that 100% means 250 millimeters per second. If you change that percentage down to say 10%, then you're talking about 25 millimeters per second, because it's 10% of the maximum allowed, which is 250. So that's 25 millimeters per second, or about an inch a second. Even an inch a second is moving pretty fast. Okay, so even when you're in jog mode, 250 millimeters per second, you're talking about 10 inches a second. That can be pretty fast. So you want to make sure that you're aware of these speed keys and you monitor your speed and use these to slow it down. So when you try to jog it, most of the time you shouldn't be anywhere near 50 or 100% of maximum speed, which is even with the limitation of 250 millimeters per second, can be very fast. There are also two speeds when you adjust those plus or minus percents. There's two speeds. When you get down to 1% and then you press the minus, you'll get down to a fine or a very fine. Now the fine and very fine are very, very small increments indeed, and so when you get down into these, you can't just hold the jog button anymore. You actually have to press it every time to get it to move. And when you're down, especially in the very fine, and you press that button once, a lot of times you can't even tell that it actually moved. It's moving so slow. All right, so this just kind of shows the speed. If you're in fine, you're going to move, if you're in joint mode, you're going to move about 0.001 degree every time you press the button. And if you're in very fine, it's actually 0.0001 degrees, which is virtually, you can't really even see that. And you can see if you're in a Cartesian mode, 0.023 millimeters in fine or 0.002 millimeters, you can't even visually see those movements. All right, so the first thing you have to do if you're going to jog the robot is you have to find the controller, and in our classroom the controllers are mounted underneath the robots inside the cabinet doors. So you have to open up the door and there's a key switch there. And so the first thing you need to do is switch that key over into what's called T1 mode or test mode or teach mode. And then the teach pendant itself also has a switch. And so you need to turn the switch on the teach pendant in on position. Now it really doesn't matter which one of these two you do first. Okay, it says here you place the controller into T1 mode first. You can turn the teach pendant on first. Either one of them, it doesn't matter which order these are done in, but they both have to be done. And the same thing when you're going back to auto mode, both of these switches have to be flipped. If one is, and if the key switch is in auto and the teach pendant switch is on, or the teach pendant is off but the controller is in test or T1 mode, either one of those, you can't do anything with the robot. All right, so both of these switches have to be switched together. Anytime you're switching them, you'll have to switch both of them to change to the other mode. If you just change one but not the other, then you're just kind of in a not move mode, and you can't move the arm in using a program or the teach pendant. Okay, so these two have to be done together. The other thing is that on the back of the teach pendant, there's two yellow switches there. These are referred to as a dead man switch. And you have to press one of these switches in. You don't have to hold both of them. As you can see there, you just use one hand. If you're left-handed, you would probably use your right hand to hold the dead man. But if you're right-handed, you would use your left hand to hold the dead man. So there's one whether you prefer left hand or right hand. But you're going to hold the dead man most often with the with your other hand, whichever one you prefer to. And so you're going to hold that dead man in, and then but when you hold it, it's actually got three positions. So if you're not holding it, then it's in its default position. But if you press it in really, really hard, then it's in the open position again. So without pressing it, it's open. Without, if you press it too hard, it's open. And so you got to hold it right there in that middle position to close the switch to allow the robot to move. And this is in case, like some of the older teach pendants, some of you may work at a place that you have a really, really old robot. And that teach pendant maybe doesn't have this middle position. It only has pressed or not pressed. But obviously what's happened at some time somebody got trapped between the robot and some other object, and the robot pushed it and they couldn't release the dead man. Okay, so the idea is that if you were like trapped and the robot's pressing you in and you can't actually release that switch, but you actually press it harder, then it's actually going to stop and prevent the robot from moving any further. Okay, so it's got this middle position, or this sweet spot, if you will, that you've got to hold it. So you just press it lightly and you'll get it into the middle position. If you squeeze too hard, then it will not move. Okay, so you've got to get it into the dead man position, or the dead man switch into the middle position. And then you have to, there's also two shift keys in blue here shown by the arrows. There's two shift keys. You have to press one of those. So, if you're using your left hand to hold the dead man, you would also use your left thumb to press the left shift key. If you're left-handed, you would probably be using your right hand to hold the dead man, and then you would use your right thumb to hold down the shift key, because you have to both be pressing the dead man into the middle position and hold down the shift key to get the robot to move. And this is for safety purposes. All right, so once you do that, you see these keys highlighted in this red box. These are the jog keys to move the axes. Okay, so depending on your type of teach pendant, usually you're going to have, if you have 6 axes, then you're going to have 12 jog keys to move each of the axes into directions. So if you're moving it, if you're in joint mode, you're going to be moving each axis individually. Okay, and if you're in joint mode, you're going to be moving in a rotational mode. The tool center point is going to be moved in a curved motion. But if you're in a Cartesian mode, the tool center point will move in a straight line. Okay, so we have a joint mode, and then we have XYZ or Cartesian mode, or we have the tool mode. So these are the three base coordinate systems we can use to jog the robot. So if you're moving it in joint mode, you're just moving one joint at a time. If you go to Cartesian, then you can move the tool center point in a straight line in the X, Y, or Z direction. Or you can go to the tool mode, which is also Cartesian, which is going to move the tool center point in a straight line, but based on the tool frame. So I mentioned in the previous slides about the tool frame. So if you're in tool mode, you're moving based on the tool center point frame of reference. If you're in one of the others, one's called world or user or jog, then you're moving the robot based on that frame of reference. Okay. So joint will move one axis at a time, but the XYZ or Cartesian frames, including the tool frame, can move all 6 axes at simultaneously to maintain movement in a straight line. Okay, the difference between the XYZ Cartesian shown here is it moves in what's called the right hand rule, but if you're in tool frame, it actually uses a left hand rule. So let's take a look at that. This is the right hand rule. Right hand rule says that if you use your right hand and kind of stick out your index finger straight out, your thumb up, and your middle finger pointing perpendicular to your index finger, then it's going to be X is pointing in the X direction. Your index finger is pointing in the X direction. Your middle finger would be pointing a Y direction, and your thumb is pointing in the Z direction. So that's the right hand rule. For the left hand rule, you use your left hand to indicate those same movements. So here's an example of the left hand. But when you're using the left hand, your thumb is pointing in the X direction. Your middle finger is still the Y, but your index finger is pointing in the Z direction using the left hand rule. So if you're in the tool frame, you use the left hand rule to determine which way X, Y, or Z is at. But if you're in one of the other frames, world frame or user frame or jog frame, you use the right hand rule to determine your direction. Okay, so the tool frame again is based on which way the tool center point is pointing. Okay, this slide actually says the faceplate, but that depends on whether you redefined your tool center point. So if you've redefined your tool center point, it's going to be wherever the tool center point is defined as. All right, so this is just showing the Cartesian here. Like I say, the Cartesian movements are, one of them is called the world frame. The world frame is based on a center point being between axes 1 and 2, where the center of where axes 1 and 2 cross would be the world frame. The tool center point, we already kind of discussed that. And so those are our 3 different frames of reference for moving the robot.